Okay, hello everyone. So welcome to the new class. That is the second class of probability and statistics. So I hope that the last class is the concepts from the last class is clear. So today in this video we are going to learn about the additive rule of probability for two cases, the by considering two sample spaces and then by considering three sample spaces, right? So before going to start the today's topic, so let's first quickly revise all the things from the yesterday's class. So in the yesterday class, the first concept that we did is uh, just a second. Okay. So the first concept that we did is the probability. What is probability? So probability is nothing but the favorable outcomes upon total number of outcomes. That's it, right? And then we discuss about sample space and then we discuss about the event. So what is the sample space? That is total number of outcome possible is nothing but the sample space, right? Just a second. Okay, so for example, if we just toss a coin, so we have the what is the possible number of outcomes? It may get head or tail. So head and tail is our sample space, right? And the third concept that we discuss is the events. Okay, so what is the event? So say for in this sample space, if I told you that what is the probability of getting head? So that is nothing but 1 by 2. So what is the event? So event is getting head while you're tossing a coin, right? That is what you known as event. And the fourth concept that we did yesterday is union and intersections, right? Just a second. Okay. Just a second. There is my cursor. Okay. So the next concept that we discuss is union and intersections. So the fourth concept is union and intersection. So what is the union? For example, we have two sample spaces A and B. So A is nothing but say 1, 2, 3, 4, right? And what is the B? That is same 4, 5, and 6. So what is A union B? That is all the unique values that are 1, 2, 3, 4, and then 5, and then 6, right? And what is A intersection B here? That is a common part, common element. So what is a common element? 4 is the common element, right? So what is A intersection B is 4. Perfect. So this is the another concept that we did yesterday, and there are two more concepts that we did. One is the mutually exclusive events, and next one is the dependent and independent events. So let's just quickly just revise all these two concepts so that we can build a really cool additive rule on that knowledge. So let's see. I will just okay. I'm not getting the controls. Okay, so let's see mutually exclusive events. So mutually exclusive events are those events that are disjoint, right? So if I take a sample space A, say 1, 2, 3, 4, right? And if I take a sample space B, that is 5, 6, 7. So now what is the value of A intersection B here? That is 5. That is empty, right? So whenever the intersection is going to be 5, that's those events are mutually exclusive events. So if you draw a Venn diagram like this, so this is event A and this is event B, so there is a no common portion. Okay, there is a no common portion. These two events are disjointed. So these two events are sorry, these two sample spaces are known as mutually exclusive events, right? So let's move further and talk about independent and dependent events. Then we will discuss about the additive rule. right? So dependent events are those events that has a dependency on it. For example, if we have event A and we have event B, so event A says that what is the sample space when rolling a dice and getting a value greater than 3. So what is the sample space? 4, 5, 6. And B event is saying that what is the probability that on the first outcome we get a 5. So based upon this sample space, what is the probability? 1 by 3. So that is, these two events are dependent, right? So if A sample space is 5, suppose we doesn't get any element that is greater than 3, we get 1 2 1 2 1 2 or 1 2 3, right? So the sample space of A is 5. So ultimately the probability is of event B is going to be 5. So B is depending upon A. So these type of events are dependent events. Okay. And the event that are independent, for example, if I say we have a sample space of 1, 2, 3, 4, 5, and 6. So that is the possible values like when you roll a dice, right? So what is the probability that the value greater than 3 occurs? So what are the sample space? 4, 5, and 6. What is the number of outcomes? 3. What is the total number of outcomes? 6. The probability is going to be 1 by 2, right? And what is the probability that on the first roll you getting a value of 5? So that is 1 by 6 in this case. Now what is the difference between both the cases? In the first case, we consider this as a sample space for the event B. So B is depending upon A. In the second case, what we did is we take a sample space of whole for both the events independently. So these two events are independent, right? So I hope these all concepts are clear. And now we are going to move further about the additive rule, right? So just move this upward. So today class is all about the additive rule, additive property or a rule, whatever you want to say, additive property slash rule. Okay, so this is based upon the yesterday's Venn diagrams class. Okay, so in the yesterday class, we also discussed Venn diagrams. I hope so you all are now pretty familiar with the Venn diagrams because it is a very simple concept. So let's build some beautiful concept on that, by considering uh, taking the knowledge of unions and intersections. So suppose we have two sample spaces. One is A, one is B. Okay, or we can say that we have two events, right? So how we can draw these two events on a Venn diagram? So very simple. So let's use some of the shapes. This one, okay, let's extend it and let's take this one as A. Okay, I hope so this will work. Okay, so let's take this one as our event A, and then let's take one more circle and mark as event B right here. Okay, perfect. So this is our event space A, this is our event space B, and let's draw some overlapping here. So this is overlapping, right? So what is overlapping part? That is A intersection B. Perfect, right? And this is our universal set, right? Okay, so we have two sample species A and B, and we plot the possible values of these two sets on a Venn diagram. So what if I told you, and if I put you a question, what is the probability of getting the response from A union B? So what I'm saying that what is the probability of getting, just a second, let's rub this. Okay, so what is the probability of getting A union B? Just pause the video and think about how you can calculate the probability of A union B, right? Okay, so let's discuss. So first of all, spot A union B on the Venn diagram. So what is A union B? Nothing but all the unique values in both the sets, right? So this is the union. Okay, so let's take an example. Suppose A is equal to 1, 2, 3, 4. Okay, let's take B. B is equal to 4, 5, 6. So what is A union B? Let's write A union B is equal to what? 1, 2, 3, 4, 5, 6. Simple. So this is A union B. So what is the probability of getting an element from A union B? Means that what is the chances of getting an element from this sample space, right? Choosing one element at a time. So what is the probability of getting two, say? So what is the probability of getting two? 1 by 6. That's all. So how you can represent this value in a mathematical format? Or let's discuss that. So think about, now just think about the probabilities, right? So probability of A union B. Okay. So first of all, let's talk about 1, 2 to 3 terms first. So what is the probability of getting the element from A? Probability of A. Getting an element from event A, we denote it using P bracket A. That is probability of getting an element from event A. Okay, so what is the probability of getting from event B? P of B. What is the probability of getting from intersection A intersection B? So now what is union? The combination of all the terms, all the unique terms. So if I say that probability of A union B is nothing but probability of A plus probability of B. Okay, so let's visualize this on the Venn diagram, right? So that it must be it will be crystal clear to you, right? Okay, so see this Venn diagram very carefully. So let's remove these lines so that you can visualize better. Okay, okay, let's remove these lines. Great. So now what is A union B? What I did is I am adding this circle, the circle A, this one, and the circle B, that is this one. So let's take some two colors. Okay, so let's take two different color pens so that you can visualize better. So probability of A union B is nothing but P of A. This is the common portion. P of A, this one, this whole circle, and the second one. What is the second one? Just take another pen. This one, that is the B wala part. So I am adding individual circles, probability of A, probability of B, and guess what? Guess one thing. We are adding A intersection B twice. Okay, so let's go some deep in this topic. So if I want to write probability of A, how can I write? Say for this portion, this inner portion, with excluding this common portion, let's say this is the X. Okay, so what is the probability of A? X plus this common portion. What is common portion? Probability of A intersection B. Perfect. Similarly, write it down for probability of B. So let's say this portion excluding the this common portion is Y. So this is Y plus P A intersection B. So now if I add P A and B in this format, so what will I get? So what will I get? Just take side bit outward. So what we will get is X plus Y plus P A intersection B plus P A intersection B. We are adding twice. Okay. So but what is the intersection part? We are just taking the unique values. Okay. So just think practically. So if A is equal to 1, 2, 3, right? B is equal to 3, 4, 5. So in this X wala part, what I am considering 1, 2. In the Y portion, what I am considering 4, 5. Okay, so what is absent in A union B? That is element 3. So this value represent 3. That's it. But here we are adding a extra 3. That is not necessary. That is not going to be the part of A union B, right? So what is the exact formulation? We just cancel this portion, and this remaining is your probability of A union B, and more likely you can say that if you write in a probability format, so this is nothing but probability of A plus probability of B minus probability of A intersection B. That's it. This is nothing but probability of A union B. Okay, simple portion. So let's move further. Let's move further. So let's rewrite the formulation. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So now you may confuse. Okay, you may confuse that here we are writing positive symbol, right? And here we are using negative symbol. This is a very common confusion that beginners can take, because PA plus PB is nothing but this value, right? So what is this value? This is PA plus P. So if I substitute this value, sorry, this whole value is PA plus P, PA plus PB. So what is PA plus PB? X plus Y plus twice P of A intersection B. And now here we are minus one element. Okay, so as I told you, when we are adding probability of A and probability of B, we are just considering the value of A intersection B is twice, right? So we have to neglect one element, like here I'm saying just neglect this element. How you can neglect this element? Just minus the single unit, the single extra unit, so that will turn out to be a formulation, this formulation, right? So don't be confused like that. Here we are adding plus and here we are adding minus, because this whole x plus y plus pa intersection b plus pa intersection b is a value of pa plus pb. So if we substitute this value pa plus pb here in this portion, that is going to be x plus y plus twice pa union sorry, a intersection b. So we have to neglect one repeated element here, so we are going to subtract one pa intersection b, right? So what we get exact here, that is pa plus pb probability of b minus pa intersection b. So this is nothing but the additive rule of getting probability A union B. This is very important, very core concept used in lots of machine learning models, right? So how a machine can identify the common terms? For example, we have two sets, or you can say that we have two clusters, two set of datas, right? So here is a one set data, here is another set data. So machine will find out the common portion, and if you like write a program to getting the probability that key, we have a data 1, say we have a data 2, and we want that from data 1 and data 2 we have to predict that in the next upcoming event what is going to happen. Okay, so we are saying that data 1 plus data 2, and in mathematics plus is an indication of union. So this is another important concept. Whenever you are doing probability and statistics, plus is representing union, or or okay, or is also representing a plus symbol, like in the electronics or semiconductor portion or some physics, we use or as a plus symbol, right? And when we are going to use multiplication, that represent intersection, the AND portion. Okay, so this is the two notations that you have to keep in your mind. Okay, so if we predict from data 1 and data 2, so that means we are considering the union, and whenever the union comes, this portion comes into picture. Okay, so this is really important in the machine learning models. So again, now you can complex the things. How we can complex the things? By considering three outcomes, three sample spaces. So let's change the color ones. So let's take blue one and right. Okay, okay. Let's take three sample spaces. So I'm not going to drive the formulation. I am just explain the three sample spaces and then directly give you the formulation. That is very easy. Just take three sample spaces A, B, C. So this is A, this is B, this is C. So this portion is A intersection B, that is A intersection C, this is B intersection C, and this middle one is A intersection B intersection C. So if you add PA plus PB plus PC here, so what you are getting? So what is PA? This portion. So PA is nothing but, say, this one is x. Okay, so P is nothing but x plus P A intersection B plus P A intersection C. This and this portion, right? And this middle one plus P A intersection B intersection C. Similarly you can write PB, similarly you can write PC, and we will come out to be a final formulation. I'm going to directly writing the formulation because the derivation is bit lengthy and not necessary as well, right? So the concept is same for the just like two sample spaces. So what is the formulation? And just writing the exact formula. So that is P A, right in the form of intersection or right in the form of union, it is same like A intersection B, just right in the form of union. Okay, so because previous formula is also written in the union form, so let's write this as well in the union form. P A union B union C. What is the getting probability of A union B union C is equal to probability of A plus probability of B plus probability of C minus extra portion of A intersection B minus extra portion of A intersection C minus extra portion of B intersection C, and finally adding PA intersection B intersection C, this middle part. Right, so this is the whole formula for the three sample spaces. Right, you can develop a formula for four sample species, five sample species, but that is not necessary. Okay, in the theoretical part we don't even goes for like sample space of four. Okay, so we stick to the sample space of two and sample space of three. So beyond this like beyond the sample space of three, doing all the things by hand is a bit difficult task, right? So that is going more complex, that is unnecessary. So just stick to a sample space of three, and if you really like want to do the works, just go for a sample space of four, right? Because after four is it is unmanageable. Okay, so let's move further. So we have two formulations. Just write both. Okay, so just write the first one, and I am going to build one more formulation out of that. So it is my recommendation for all you that just don't just cram the formulas, right? So I am here, I am first drive the formula and then tell you the final exact formula, you know. So what is the purpose of derivation? The purpose of derivation is that you can understand the things, you can feel the things. Okay, so if you just cram the formula, you are not able to make any machine learning model. You have to feel the things. Okay, you have to know the understanding of the concept. So what is the formulation here? That is P A union B is equal to P probability of A plus probability of B minus probability of A intersection B. So yesterday we'll discuss one concept, that is mutually exclusive events. So say I am adding a assumption here: if A and B are mutually exclusive. So what is the output? What is the value of A union B? So let's write: for mutually exclusion, P A union B is probability of A plus probability of P minus phi, because in mutual exclusive events the intersection is going to be phi, because what is a Venn diagram here? This one. This is A, this is B. Both events are disjoint. Okay, so there is a no intersection part. So what is the value? P A union B, probability of A union B is nothing but probability of A and probability of B. That's it. Simple part. So this is for the mutually exclusive events. Okay, so this is pretty simple, and yeah, this is pretty simple. That's it for today's lecture. So let's compile all the things together. So in today's lecture, we learn the additive rule. So what is the main thing of the additive rule is just draw the Venn diagram and compile the things together and remove the extra portions. That's it. You will ultimately, make a one simple formulation. So no need to cram any formula, no need to just remember any formulations. Just remember the concept. Just remember the flow sheet, flow. How you can build that formulation. Just do derivation 2 to 3 times. If you are a beginner, repeat the derivation 2 to 3 times, and ultimately you will understand whole theory and whole concept. Right. So let's compile today's lecture. So today's lecture, what we will discuss is additive rule, that says if you want to know the probability of A union B, that is a composition of sample A and sample B. So that is nothing but probability of A plus probability of B and minus probability of A intersection B. You can generalize this part as well, like this: probability of A union B union C up to n elements, that is equals to probability of A plus probability of B plus probability of C up to probability of n elements and minus n extra elements. That's it. This is a general formulation. Right. Okay, so that's it for this lecture. I hope that the additive rule is clear to you. I know it is for some people that who are doing probability and statistics for the first time. They feel this concept a bit difficult, but just revise the things. Okay, just do these things 2 to 3 times. Try to make the formulation through derivation by your own, by yourself, and then repeat the video. See this video again 2 times, 3 times, 4 times. Ultimately, you know what is going to be the exact answer, right? So the best way to learn this thing is by considering the values. Okay, so just consider, for example, sample A is equal to 1 2 3 4. Okay, and consider sample B is equal to 4 5 and 6. Okay, based upon these values, try to compile A union B. Okay, so ultimately you will land up to a correct formulation. Okay, so that's it for this lecture. I hope this lecture is clear. So if you're really loving the lectures, just please subscribe to the channel and please share the video to all the people who really want to learn about AI and build their own custom models from the scratch. So this is going to be really helpful for those people. So take care, goodbye, and we will meet in the next lecture. Thank you.